Hey boys and girls, today we're going to start Unit 5, which is Geometry and Measurement. Unit 5, Module 1 is all about measuring angles. So Session 1 would normally be our Unit 5 pre-assessment, but we're going to just jump right into the lessons instead. And in this module, we're going to identify, draw, compare, analyze, and classify angles. We will study angles by themselves and those in two-dimensional shapes. We're going to start by looking at student book page 163. This is just kind of to recall prior knowledge, okay? So I'm going to go ahead and read the first problem. It says that Elena traveled from Istanbul to Ankara, which is 351 kilometers. Then she went from Ankara to Marmaris, which is 527 kilometers. If it is 468 kilometers back to Istanbul, how far did Elena travel in all on her trip? Show your work. So basically what we want to do here, and you can go ahead and write this in your page, is we want to take 351 plus 527 plus 468. Now if we add all those together, 8 plus 7 plus 1, that's 16, okay? 5 plus 1 is 6, 6 plus 2 more is 8, and 8 plus 6 is 14. And then 1 plus 3 is 4, 4 plus 5 is 9, and then 9 plus 4 is 13. So altogether, Elena would have traveled 1,346 kilometers. Okay? For number 2, it says Elena and her brother ate cookies on their trip. Elena ate 2/4 of her cookies, and her brother ate 2/3 of his. Elena says that they ate the same amount because they both have 1 cookie left. Is that correct? First of all, no, that is not correct. And there's 2 different ways you can solve this problem. So if Elena ate 3/4 of her cookies, imagine that she actually had 4 cookies and she ate 3/4 of them and she has 1 cookie left, right? And imagine that her brother only had 3 cookies and he ate 2 of them. And he has 1 cookie left. Notice that she ate 3 cookies and he ate 2. Another way you can look at this problem is you can go like this, and you can actually draw fractions to solve this one. And you can kind of just color in 3 and color in 1, and you can clearly see that Elena ate more cookies than her brother did. So there's 2 different ways that you can solve that problem. So it says, is she correct? No. No, she is not. Okay, and then this picture explains why. Because she ate 3 and he ate 2. Or you can just simply say that 3/4 is greater than 2/3. Okay? Which of the equations is not true when you look at number 3? Well, 1.25 or $1.25, if you think about it that way, is actually the same as 1 1/4. So that one is true. We're going to leave that one alone. When I look at 6 5/100 versus 6 5/10, I know that 6 5/10 is greater than 6 5/100 because 6 5/10 is actually the same thing, as 6 50/100, and 6 50/100 is greater than 6 5/100, which means that that one is correct, right? When I look at 2 4/100 versus 2 4/10, it's kind of that same idea. They're not equal. So this one right here, I'm sorry, my Apple Pencil is giving me issues here, and this is so small that I have to use it to write. So give me just a second here, I apologize. Hopefully it lets me fill that in. There we go. Okay. And then when I look at the other one, 4 1/4 versus 4 1/5. 4 1/4 is greater than 4 1/5. So the correct answer for number 3 is this one right here. For number 4, list all the factor pairs of 63. I'm just going to go ahead and do this over here because it's easier. We have 1 and 63, right? 63 is an odd number, so 2 does not go into it. But 3 and 21. 4 does not go into 63, and 5 does not. Neither does 6, because 6 goes into 60. but 7 and 9 both go into it. So here are your factor pairs right here. I believe you remember this from the way beginning, those rainbows that we were making at the beginning of the school year. Okay, so like I said, this is kind of a recall prior knowledge. And number 5, fill in the missing information on the multiples wheel. All right, well, 15 times 3, that's 45. I'm just going to fill this in for you and let you fill it out in your paper. 15 times 5, that's 75. 15 times 4, that's 60, because I know that 15 goes into 64 times if you think of a clock. 15 times 8, well, that's double, right? 15 times 2, let's see here. Well, if 15 times 4 is 60, then 15 times 2 is 30. 15 times 24, that's 360. 15 times 16, wow, that's 240. And 15 times 20, well, if 15 times 2 is 30, then 15 times 20 is 300. And then 15 times 12, that's 180. Looking back at this other one over here, 30 times 3 is 90. 30 times 12, well, if 15 times 12 is 180, then 30 times 12 must be 360. 30 times 2 is 60. 30 times 20 is 600. 30 times 8, well, if 15 times 8 is 120, then 30 times 8 is 240. It's just double that. 30 times 4, so 15 times 4 is 60, so 30 times 4 is 120. All right. 15 times 16 is 240, so 30 times 16 is going to be double that at 480. 15 times 24 is 360, so 30 times 24 is going to be 720. And then if 15 times 5 is 75, then 30 times 5 is going to be 150, okay? And then round 15,615 to the nearest 10, that would be 15,620. If we round it to the nearest 100, it's going to be 15,600. If we round it to the nearest 1,000, it's going to be 16,000. And if we round it to the nearest 10,000, it's going to be 20,000, okay? So that is our recalling prior knowledge page. Okay, moving on. So today we will consider the similarities and the differences between kinds of angles by identifying which angle does not belong in various collections of 5 angles. We're going to learn about the zero angle, the acute angle, the right angle, the obtuse angle, and the straight angle. So you probably remember many of these already because of doing number corner, which is awesome because that's going to help us tremendously. So a zero angle obviously is going to measure 0, right? Acute, when we think of an acute angle, it's such a cute little angle, right? And it can open up this way or it can open up this way, okay? And then you have a right angle, which if you remember correctly, sometimes they have that little square corner, and a lot of times I can take my paper and I can stick it in a right angle, and if it fits perfectly, it's a square corner, it's a right angle. Obtuse angles are going to be those obtuse. If you remember me saying that when we were back in school, they're very big angles, right? And then a straight angle is just like that, okay? So you have acute, right? 0 would be a non-angle altogether. And then acute, obtuse, and straight angles. All right. Okay. So we're going to work with angles for the next few days. We've talked about angles in number corner, like I mentioned. Remember that an angle is a figure formed by 2 rays, or line segments, and they share an endpoint. Okay, so here would be that endpoint that they share right here, okay? Often measured in terms of the amount of rotation, expressed as some number of degrees. So acute angles would be less than 90 degrees. Obtuse angles would be more than 90 degrees, okay, and things like that. So all of these, this picture that you see right here, all of this is angles. All right, so what I want you to do now is I want you to open up your student book to page 164, please, okay? I want you to take a look at this page from your student book and just think about it. Take a couple of minutes to circle the angle that doesn't belong in each of these 5 problems, and you're going to post it in Seesaw, okay? So when you're looking at number 1, there are 5 angles in each of these boxes. and there's just one that does not belong, okay? So think about it. I'll give you a little bit of time to fill it out. Just circle. This shouldn't take a lot of time, okay? And then I'm gonna flip to the next slide in just a minute, and you're gonna check your work. And if you got them correct, I want you to give yourself a star, a smiley face, or a check. And if you didn't, you may go ahead and fix it, and then you're gonna post it in Seesaw. I'm very sorry, boys and girls. I have a sore throat today, so I'm sorry if I sound hoarse. Okay, I'm gonna go ahead and flip to the next slide now. As you can see for number 1, this is the one that does not belong, okay? You can see that has an arrow going both ways, and the other ones all have arrows going the same way. So these would all be considered, the rest of them are 0 angles, and the other one's a straight angle. Number 2, the one that doesn't belong, is this one right here. And the reason why it doesn't belong, and my Apple Pencil is giving me issues again, but the reason why that 3rd angle doesn't belong is because it is the only obtuse angle, and all of the other ones are acute angles. So that is why that one does not belong, okay? For number 3, the first one doesn't belong, and if you look really, really, really carefully, all of the other angles are right angles, and that's the only one that is an acute angle. So that would be why that one doesn't belong. And then for number 4, the second one doesn't belong, and the reason why is because that is the only right angle in that one, and all of the other ones are obtuse angles, meaning that they measure more than 90 degrees, okay? And then for number 5, the one that doesn't belong is the second one here, because this would be a 0 degree angle or a 0 angle. All of the other ones would be straight angles, where you have those 2 rays coming together, and straight angles measure. So if you think about it, a 0 angle is 0 degrees, right? Okay, an acute angle equals less than 90 degrees, okay? A right angle equals 90 degrees. It's exactly 90, no more, no less. An obtuse angle is more than 90 degrees. I am going to fix something right here. Oh my goodness. With acute, it would be less than 90 degrees. I am sorry. And then with obtuse, it's going to be more than 90 degrees. So acute is less than, obtuse is more. And then when you have a straight angle is simply going to be 180 degrees. And if you think about it, it's 2 right angles put together basically, so it's a straight line, okay, and that measures 180 degrees. All right, so let's go over these real quick here. So a 0 angle is an angle whose measure is 0 degrees, and you'll notice that you have, it's almost like a clock, like 12 o'clock if you think about it. So it's kind of like 2 rays, but they're one's on top of the other, so they don't have any measurement, they're not separated, and it's 0 degrees, okay? For a straight angle, it's 2 angles put together, so it's an angle with a measurement of exactly 180, no more, no less. It's perfectly straight, and the difference between these two is that with this one, the rays are on top of each other. With this one, they're facing opposite directions and they meet in the middle, okay? So 180 degrees. For an acute angle, that's an angle measure that is less than 90, so it's anywhere between 0 degrees and 90, so it's more than 90, but it's, I'm sorry, more than 0, but less than 90, okay? So it's very cute. Think about a cute little angle, okay? So 1 degree would be considered a acute angle, and 89 degrees would be considered a acute angle, and anything in between there. For a right angle, that's an angle with a measure of exactly 90 degrees. So with a right angle, sometimes you see a square corner and sometimes you don't. If you don't, I know in the classroom we would always put post-it notes on our angles to see if our post-it note corner would fit perfectly. If you have a perfectly square corner piece of paper, you can always check a right angle that way, but it's going to be exactly 90 degrees. And it's important to be able to tell whether or not an angle is 90 degrees. And oftentimes, like I said, you can hold the corner of a piece of paper to check. An obtuse angle is an angle with a measure greater than 90 but less than 180. So anywhere between 91 degrees and 179 degrees would be an obtuse angle. So obtuse, think very big. When you look at this one right here, it almost looks like a straight angle, but it's not. It is less than 180. So it opens wider than a right angle. Okay, so here's a picture of something. So if we were in our classroom right now, we might be able to use things that we have to check. our angles, okay? So you can see in this picture right here, holding a piece of paper or a pattern block to kind of see that, oh, this is an acute angle because it's not exact. It's actually less than the corner of that piece of paper. This one right here, we could use one of our pattern blocks again, and we could see, oh, it fits perfectly into that right angle. And then if we were to use our flat, that, you know, our 100 block that we have been using before we left school, we can see that the angle is actually larger than the flat, so which means it's obtuse. So we have acute, we have a right, and we have an obtuse angle right here in this image, okay? Okay. So remember the definitions for later. 0 is an angle that measures 0 degrees, and it's going to look like this or like this. Okay? A straight angle is going to look like this. It's going to have its central point, and it's going to measure 180 degrees. An acute angle, it might open this way, it might open that way, right? And it's going to measure less than 90, okay? A right angle is going to be just like the corner of your piece of paper. Sometimes you'll see that, and sometimes you won't. You have to be careful, okay? But it's going to be exactly 90 degrees, okay? And then an obtuse angle might open this way, it might open that way, but it's going to measure more than 90. However, it'll measure less than 180, okay? All right. Okay, so now what I want you to do is open up your student book to page 165. Now we're kind of looking at pattern block angles. Unfortunately, we're not in our classroom, so we can't look at these pattern blocks and hold them in our hands and things like that, but we're going to use the words 0, acute, right, obtuse, or straight to label each angle, okay? Now when I look at this hexagon that I see for number 1, if I look at it very carefully, a hexagon has 6 sides, and my friends, it also has 6 angles. When I look really carefully at each one of these angles, okay, look at that. They're all bigger than the corner of a piece of paper. And if I look at this corner right here, all of those angles are larger. These, my friends, are all obtuse angles in this. So we would write all obtuse angles for this one. For number 3, we have a trapezoid, okay? When I look at my trapezoid, it has 4 sides, it has 4 angles, okay? Now, when I look at this angle and this angle, they are the same, right? So both of these angles right here are bigger than this corner right here, and that's a 90-degree angle. So both of these angles are obtuse. When I look at these angles right here, they're both smaller than the corner. So this one and this one, these are acute angles, okay? When I look at number 3 is actually an equilateral triangle. And if you look really carefully at it, all of the sides are the same length and all of the angles are the same. That means that all of these angles right here, they are all acute angles. All right, moving on to number 4, we have a square. All equal sides, all equal angles, okay? Now, we all know, if you think about it very carefully, a square, it's called a square, my friends, for a reason. It has 4 square corners. So these are all, another name for a square corner is a right angle. So all right angles, okay? And then for number 5, when I look at this image very carefully, okay, this is like a rhombus. It's kind of like a square that was stretched out. So these are 2 different rhombuses actually for 5 and 6. So this right here, this is an acute angle, and this is an acute angle. When I look at this one and this one, this is obtuse, and this is obtuse. Go ahead and make sure you're filling this out on your student book, page 165 as well. And when I look over at this one, we have an obtuse angle here, and we have an obtuse angle here. And then we have a really acute angle, acute, and acute. Okay, so technically I should have made all the acute angles red and all the obtuse blue and all the right green, but I did not do that. I'm sorry. Anyway, so there's page 165. Go ahead and fill that out. Submit that into Seesaw as well so I can see it. And finally, okay, so you're going to be doing 2 pages on your own, but before you do those, I'm going to go ahead and just do this last page with you, okay? So the last page I'm going to do with you is student book page 166. Write acute and obtuse angles. Think about what kinds of angles you see, okay? So it kind of gives you a little information here. A right angle is exactly 90 degrees, okay? An acute angle is less than 90 degrees, and an obtuse angle is more than 90 degrees. So for this one, it says circle all the right angles. Well, I can see that they have square corners. I have 1, 2, 3 right angles here. Okay, for B, circle all the acute angles. Find all the ones that are less than 90 degrees. Do you know what I think I'm going to do? I'm going to stop here, actually. I would rather you did this on your own. This is actually going to be a good review for you, so I want you to finish student book page 166. So you finished student book page 166, okay? I did the first one for you. You're going to do B, C, 2, and 3. You do that, and then you are also going to do home connection page 89, which is a review of area and perimeter, okay? Remember that perimeter is the distance around something. If I were to walk around a garden, for example, it would be how far did I walk, right? The distance around something. So you can see with perimeter, it would be 3 plus 3 for this side, plus 5 for this side, right? Plus 5 for the other side. And if I were to add all those together, right, I would have 3 plus 3 plus 5 plus 5, right? Okay. But then the area would be the space it takes up. So like how much rug space does it take up? So that's where you do the 3 times the 5 and you get 15, okay? So I want you to do home connection page 89 and home connection page 90 for homework tonight, okay? All right, boys and girls, that is your homework for today. And that was your lesson. So have a great rest of your day. And thank you so much.